Hello everyone. In this video, I will be showing how to use the LED board and switchboard, the one which you see in the hardware and which are physically available in the kit which we have. So see in this program, once I run this program, the three LEDs, they blink regularly. And when I press 0, this is a push switch. Then all the 8 LEDs, they start blinking. And when I press 7, the program goes back to the original blinking. 0 initiates an interrupt and gives a warning. And bit 7, push switch 7, once I press this one, the program is back for its original state. How do we do that? I'll show you by starting a new program. New project. Level 011. Okay. From the components library, we go on to the hardware and we select block 2 LED. And we select switch. This is a set of 8 switches. This is also available in the kit which we have in the college. we're going to put these push switches on port A, and LEDs on port B. Now we make a little program, put in a loop. Output is on port B. So we go on to the advanced so we want the first three LEDs to blink. The first three LEDs, in order to make them blink, we should be sending out a number 4 to 1, that means 7. If we send number 7, then the last three LEDs will start blinking. Five hundred milliseconds. Okay. Okay. Now, if you run this program, see these last three LEDs, they start blinking with a gap of 500 milliseconds. 1 and 0, 1 and 0, all 7 and 0, 7 and 0 is being given out. Now, what we want is that once we press push switch 0, all the LEDs should light up. So for that, we're going to use an interrupt. We put in an interrupt here. Enable interrupt, interrupt on INT 0 pin. Create new macro. Name of the macro is stop. Okay, and edit macro. Now a new tab comes up here on top. The one is main. This is the main program, and this is the stop macro. We need to program this macro. In a loop. And so either we can use this output symbol to give an output to switch on all the LEDs, or we can use an another symbol, all on. So this will switch on all the LEDs. Port D, and give a delay 250 milliseconds. This will be a little faster. And then we switch off all the LEDs, and then we again give a delay of 250 milliseconds. No. We want, now if we run this program, all the LEDs will start blinking once we press 0. So let's run it. Now how to stop this interrupt? We need to clear within the interrupt, within the stop macro, we need to have some kind of code which will stop all the LEDs blinking. So we say while until expression, we say clear is equal to 1. It's going to say where is the clear variable. So yes, we want to make a new variable named clear. It should be byte. It could be Boolean as well, because all we want is only 1 bit. Okay, now we have created a clear. So once we're going to press 7, so we need to now put us 1 in bit 7. Once we press it, the clear variable should have 1. So we will have an input. Input on port A, but on it should be only on single bit. So we say number 7 bit, and it should store in the variable clear. So this loop will run until A7 is 1. Okay, let's run it. Press 0, all the lights start blinking. Press 7, and it goes back to its original program. Apparently it looks okay, but if I repeat it, will it work? Let's see. Now I'm pressing 0, but it is not interrupting. What could be the reason? The reason is that the variable clear, it has 1. Till the time variable 1 is there, it will not interrupt. Therefore, I need to make sure that the variable is 0. In the main program, I have cleared it. Now all the bits are blinking. I press 7. Program goes back. I press 0 again. All the bits start blinking. I press 7. The program goes back again. So that is how you're going to use the interrupt on the LED board and switchboard. These are the hardware components which are available in the microcontroller kit with us in the college. I hope it was useful.